Hello and welcome. Here we go. Bark is a parallelogram. Angle A is 99. Solve for R, K, and B. Okay, well, and these parallelograms, we know that our consecutive sides are going to be supplementary because these are parallel. So this makes this the same side interior angles. So we just have to say what plus 99 equals 180 or 180 minus 99. Which gives us 81. And then we also know that because these two are also going to be same side interior, this would be 99 and this would be 81 because that's the only way it could happen. So it means opposite angles in a parallelogram are congruent. So there you go. K, 99. R, 81. B, 81. All right, moving on. Bark is a parallelogram. AB is x plus 24. AR, I put that in the wrong spot. X plus 24 goes there. This is 4x plus 15. RK is 3y minus 11. And KB is y plus 40. Okay, we actually know that opposite sides are congruent. So these two are congruent to each other, and these two are congruent to each other. So we haven't seen this math in a while, but this is our basically we're going to set these two equal to each other, but we have two variables that are kind of not the same. So we start with our first equation, which is x plus 24 equals 3y minus 11. We have our other equation that's going to be 4x plus 15 equals y plus 40. So the problem is we can't solve either of these, but I can use the power of substitution, which is one of our systems of equation technique. I have two equations with two variables, so if I solve this for y by subtracting 40, I could get y equals 4x, and then 15 minus 40 is negative 25. Now, I have y is equal to this piece, so I could plug this in to that equation and solve. So that's what I'm going to do. So I'm going to get x plus 24 equals 3 times what y equals, which is 4x minus 25 from the other equation. And now everything's in terms of one variable. That variable is x. I distribute the 3. 3 times 4 is 12x. 3 times that is negative 75 minus 11 equals x plus 24. We combine like terms, 75 and 11 is going to give me a negative 86. All right, and I have more x's over here, so I'm going to subtract the x this way and add the 86 this way. If I do that, I end up with 11x on this side. And if I add 86 to 24, I'm going to get 110. And if I divide 11, or 110 by 11, sorry, 110 divided by 11, I should get 10. So x equals 10. And then I have to plug it back in. Doesn't matter which one I'm going to plug it back into. I'm going to plug it back into this one up here. Actually, no, let's plug it back in here because it's already set up. This is going to be 4 times 10. So 4 times 10 minus 25 equals y. That's going to be 40 minus 25 equals y. And 40 minus 25 is 15. So we get 15 for y. Again, geometrically, pretty easy. We set opposites equal to each other, but algebraically, we have to use a little bit of our substitution property. All right, number 3, RKG. Remember, K is our vertex. It's right in the middle. So R and G go down to K. So 49 is this guy right in here. AGR, so I'm looking at G as the middle. A and R going to G, so 82 is right here. Solve for RGK, so RGK, so I'm going to look for this guy here, X, and ABG, I'm going to solve for this piece called Y. Okay, this is just a parallelogram, so we can solve for this using our skill set here. Basically, these two are a linear pair, so to find x, I could do x plus 82 should equal 180. And then if I just subtract the 82 from both sides, I should get x equals 98. And x is the RGK. So that's now going to be 98. And which means this is 98 over here because of vertical angles. And then 49 right here. Remember, these are parallel, RK and AB. And it happens to be that AK happens to be a transversal. And so that means this 49 is also over here as alternate interior angles. And now I know all three of these angles should add up to 180 because they are a triangle. So if I combine 49 and 98, I get 147. And then if I subtract 147 from 180, I should get y, which is 33 degrees. All right. Ooh. Like those were some heavy hitters in the beginning. All right. AG is 4x plus 7, and KJ is 2x plus 33. This is a parallelogram right here, and we want to find x. Well, part of our parallelogram rules is diagonals bisect, so we actually know that these are congruent. So we're going to just set these equal to each other and solve. I'm going to subtract the 2x over to leave me with 2x. I'm going to subtract the 7 over. So I'm going to subtract the 7, subtract the 2x. So we left with 2x. And then 33 minus 7 is going to be, and again, I just checked with my calculator. I don't want to make a mistake here. Divide by 2. X equals 13. All right. Determine whether the quadrilateral is a parallelogram using the distance formula. Okay, so first things first, I kind of like to get a rough idea of what this shape is going to look like. But if we want it to be a quadrilateral or parallelogram, we can say distance formula. We have two sets of opposite sides that are congruent. So I do have to run through the distance formula a couple times here to do this, which is no skin off of my back. We can do that, no problemo. And so, but it is sometimes nice to kind of just set up and see what it looks like. So 1 second. Sorry, here we're back. Okay, so I got the distance formula all written out here. Here's the distance formula. We solved them real quick. So we see that the two opposite sides are congruent, rad 50, rad 50, and the other two, rad 104, rad 104. So this is, in fact, a parallelogram, yes. The next question says using slopes. So our slope formula is y2 minus y1 over x2 minus x1. And if we run through all the different slopes, we should have parallel, opposite sides are parallel, which means we have two sets of congruent slopes. And see, we have two right here, 1/2 and 1/2, so those are parallel. But then we get 7 over 5 and negative 8 over 7, not parallel, so we would say this is not a parallelogram. And then last but not least, using both, if we can show one set as parallel and congruent, just one set, we're good. So if we see BC and DE, they're congruent, and BC and DE are also the same slope, which is parallel, we can say that they are, in fact, a parallelogram. Okay? So a lot of calculations on those two. Okay? All right. What is the Pythagorean theorem? When do you use it? I can answer this. A squared plus B squared equals C squared. When do you use it? To find a missing length in a right triangle. You do have to have two of those. Okay, so here we go. Here's our example. This is going to be C is the hypotenuse that is along the sides. We're going to get A squared plus X squared equals 17 squared. This is 64 plus X squared. You would think I would know 17 squared off the top of my head. I did not. Subtract the 64, and we get X squared equals 225 by subtracting that 64. Square root that. And when we square root that answer, we find out that we get a very convenient answer of 15. All right. Leave an exact form. So exact form means I'm not going to leave it as a decimal. I'm going to leave it as a square root of some sort. So this can be 10 squared plus 11 squared equals X squared. I can plug all that in my calculator one step just like that. And we get 221. 221 equals x squared, square root it, and I can square root in my calculator, and it doesn't go anywhere as I knew, but there we go. That would be the exact form, not decimal form. Determine whether the three sides create a triangle. If so, classify. So first step, so step 1 is, are the two smaller bigger than the largest, right? So that's what we got to check first. Is this true? If it's true, we get to move to the next step. Okay, and 18 is bigger than 12, so yes, we have a triangle. 9 and 12 is bigger than 15, yes, and yes. So we have a triangle for all three. Now we have to classify. So step 2, we classify, and we do the same thing, but this time we square them. And we say, what's its relationship to this guy? Okay, so this is going to be 8 squared plus 10 squared, which is going to give me 164. And what's the relationship to 144? Well, if the bigger guys win the battle, if the big guy wins the battle, it's obtuse. If the little guys win the battle, it's acute. If it's congruent, it's right. So here the little guys win the war, it's acute. All right. Next, we get 9 squared plus 12 squared. What's its relationship to 15 squared? So again, I'm just putting in 9 squared plus 12 squared. 225, and that's 225. So those are equal. So that's going to be a right triangle. I'll switch colors here because it's blending all together in my head. 31 squared plus 35 squared. What's its relationship to 39 squared? And that's going to be a pretty big number, 2186. I'm guessing 39 squared is going to be pretty big as well, but not as big. And so the little guys, again, are bigger. They win the war. So this is acute. No obtuse on that one. All right. A 20-foot ladder is leaned up against a house if the base of the ladder is 9 feet away. Okay, so basically I'm just going to write a right triangle. This is my house. A 20-foot ladder is leaned up. This is the leaning of the ladder. If the base, the bottom of the ladder is 9 feet away, that's 9 feet. How high up does the ladder reach? And so I'm guessing this is x. This is just Pythagorean theorem. So we're just going to get x squared plus 9 squared equals 20 squared. And so 20 squared and 9 squared, we get x squared plus 81 equals 400. Subtract the 81 from it, we get x squared equals 319. It says round to the hundreds place, so this time I'm just going to square root 319 and get a decimal, which is 17 point, and hundredths, that's tens, that's hundreds. So look at the one after it, 1,000, doesn't round up, so it's just be 17.86. Okay. All right. Okay, next, solve for the triangle. So here we're using our special right triangle, so I'm going to apply our rule of L, rad 2, okay? And so here, if L is equal to this part, we can just actually divide by rad 2 to get what L is. And 10 divided by rad 2, well, you could use your calculator, and it will rationalize for you to get 5 rad 2. We did know the shortcut, divide by 2, multiply by rad 2. Or you could do the old school way and actually fully rationalize, which is 10 rad 2 over 2, which reduces to 5 rad 2 for our L, which means these two are both 5 rad 2. All right. Next one, we apply the rule. Again, it's 45, 45, 90, so L rad 2. We know what L is, so it makes this very easy. This is going to be 8. This is going to be 8 rad 2. All right, new rule on this one. Across from the 30 is L. Across from the 60, L rad 3. And across from our 90 is 2L. So this means L is going to be half of 18, which makes this 9, which makes this 9 rad 3. We're cruising now. Okay, and this one is L rad 3, L, and 2L. And again, here we can divide by rad 3, put it in our calculator and figure out what L is, or we can just remember, divide by 3 and multiply by rad 3. So that's going to be 3 rad 3. So this is 3 rad 3, and this is going to be double 3 rad 3, which is going to be 6 rad 3. So we get 6 rad 3 for y and 3 rad 3 for x. All right. Write the ratio of sine, cosine, and tangent. So we know that it's so, ca, toa. And we're from the A. So the A is where we're going to put our googly eyes. So we're going to put our googly eyes on A because it's looking at A. So from the perspective of A, this would be opposite, this would be adjacent, and this, of course, is the hypotenuse. So we just have to do our due diligence and our ratio. So O over H, that's just going to be 12 over 37. A over H, 35 over 37. And O over A, 12 over 35. And you're done. But SOHCAHTOA is not done. We have this guy right here, solve for x. So we don't have enough information to use Pythagorean theorem. We'd have to have two sides. We don't. So we're going to put our googly eyes right here. I have opposite and a hypotenuse, so OH is sine. So we're going to take sine of the angle I'm looking at equals opposite over hypotenuse. Now, we said if x is in the denominator, we can just switch these two out algebraically. So that's x equals 23 over sine 37. And we want to make sure our calculator is in degree mode, so there should be a little d up there. D for degrees, 23 divided by sine 37. Don't forget to close your parentheses, just as good habit. And we get 38.21. And I look at my picture, and does that seem reasonable? My hypotenuse is 38.21. It's bigger than 23, which it should be, as hypotenuse is the largest side. So that seems reasonable. I didn't get a number smaller than 23, so that makes me happy. All right, from here, googly eyes. We have opposite and adjacent, so we're going to use tan. Tan x equals 29 over 21. Now, to get rid of a tan, we do tan negative 1 and tan negative 1. And this cancels that out. Whoop. And so we get x equals tan negative 1 of 29 over 21. By the way, this is tan inverse. So you just do shift tan. That gives you that tan over negative 1, or the inverse of tan. And 29 divided by 21. Close parentheses. And we get 54.09 degrees. And it seems somewhat reasonable, right? 29 is bigger than 21. 54 is going to be bigger than whatever this angle is, because I know these two have to add to 90. So I know that will be smaller. So it seems reasonable enough to me. Number 20. 10-foot ladder rests on the side of a home. We've already seen ladders today. So there's my 10-foot ladder. Here's my home. If the 7 feet away from the base, what angle does it make with the ground? So the angle in the ground and the ladder is right there. So we're going to be using our googly eyes here. We have adjacent and the hypotenuse. We're going to use the cosine of x equals 7 over 10. And just like we use inverse tan, we're going to use the inverse of cos to cancel that out. But whatever you do to one side, you have to do to the other. So we're going to take the second cosine of 7 divided by 10. Close parentheses, that's a good habit. 45.57. 0.57 degrees. It's not saying what to round to. Again, the final is multiple choice, so that shouldn't be an issue anyways. All right. Law of sines. So law of sines, we need two sets of opposites. So I see one set of opposite right here, but my other set of opposites I don't have. I do want x involved, so that means I need to find this angle, which I'm in luck, I can do pretty easily. I know that 37.99 should, and this should add up to 180. So if I took 180 and I subtracted 99 and I subtracted 37, I should get that leftover value of 44, which is exactly what I want right here. And remember, the rule is you take the sine of the angle over its opposite side, and sine of the angle over its opposite side. And then we just cross multiply. So we get x times the sine of 37 equals 17 times the sine of 44. And I want to get x alone, so I'm going to divide sine 37 on both sides. Goodbye. And so basically this is what I need to set into my calculator right here. And so I like to evaluate the top first. 17 times sine 44. I hit enter, so that's the top piece. Then I hit divide, so I'll take that answer I just had, divide it by sine 37. I do this because in case you forget to close parentheses, it will save your booty. So 19.62. And again, I look at this as 19.62 reasonable. And 44 is bigger than 37, so I'd assume this blue line would be longer than this line, which it is. Not much longer, but 44 is not much bigger than 37, so it seems reasonable to me. Law of cosines, I only need one set of opposites, which I already have. So I'm going to set up my equation, by the way, which is a squared equals b squared plus c squared minus 2a b times c times the cosine of a. And so if we see, we have our opposites set up in our equation. This is our side lengths, and capital is our angle, so this is going to be x squared equals, now these are interchangeable as b and c, doesn't really matter. Just pick one of them. I'm going to pick 29 as my b, and 21 is my c, and cosine of the angle 113. Now the beauty is I can put all of this in my calculator in one step, and I will do that now. 29 squared plus 21 squared minus 2 times 29 times 21 times the cosine of 113. Hit enter, and I get a huge, huge number, and I'm thinking that's not right, and the answer is it isn't right. I actually didn't make a mistake in my calculation, though. It's just that this is set equal to x squared, which means I do need to square root this. So I'm going to take this and I'm going to say square root and click my answer button. So I'll take the answer, that's 1757.91 in my calculator, hit enter, and I get 41.92. Is that reasonable? Well, I would say it is pretty reasonable because 113 is a very large angle for a triangle because you can only add to 180. And so it means it should be pretty big side over here, and these are 29, 21, so it's got to be much bigger than that. 41 seems to fit the bill. All right, find the measure of one exterior angle of a 42gon. Well, we know that the sum of exteriors is 360, and if it's a regular 42gon, then we should just basically take 360 and divide it by 42. That should tell me one of the exteriors, so 360 divided by 42, and I'm going to get about 8.57 degrees. So that's what you do. Find the measure of one interior angle of a, so well, the sum of interior is actually n minus 2 times 180. So I'm going to do 32 minus 2 times 180. So that'll be basically 30 times 180. So I get my sum is 5,400. So the sum of the interior is 5,400. It should be a regular polygon we're referring to, so we're going to take 5,400 divided by 32. And what you get? 168.75 degrees. Alright, so the sum of the interior, we're going to use the same formula as up here, so 28 minus 2 times 180, so that's basically 26 times 180, and we get 4,000, I'm sorry, you couldn't even see my answer over there, 4,680. The sum of the exteriors of the 72gon, everyone is 360, okay? Lightweight. Wait, baby! Okay, the sum of the interior of regular polygon is 2,340. How many sides does the polygon have? Well, I just take the formula n minus 2 times 180, and I set it equal to my sum, and now I solve. Well, to solve this, we just divide by 180. That will cancel that out. Divide that by 180, so 2340 divided by 180 is 13. N minus 2, add the 2 over, and n equals 15, so it's 15 sides. if the measure of one interior angle of a vertical polygon is 165, how many sides does the polygon have? Now this is where I like to cheat. So check this out. If this is an interior angle, this is the exterior angle. That means they add up to, that's right, 180. So what over here would add up to 180? Well, here's the cool thing. Take 180, subtract 165, you get 15. So 15 degrees. So how many times would 15 fit into 360? Because that's the sum of every regular polygon. So if I took 360 degrees, I said, how many of those 15 degrees would fit in there? That should tell me how many sides I have. So 360 divided by 15, that means I should have 24 sides. And then you can always work it backwards if you want, but that's how I would do it. If the measure of one exterior angle of a vertical polygon is 12, how many sides? So this is where we can just take what I just did above and just say, well, how many 12s would fit into 360? That should be how many sides I have. And the answer to that is 30 sides. All right, we're making our way downtown, walking fast, moving fast. Okay. Do you feel like that 12 didn't make it to the right spot? That's what I'm feeling. So let's go ahead and let's just say this 12 was up here, because I don't think that's where it was supposed to be at all. Anyways, so let's go ahead and find the missing lengths. I'm going to break this up real quick. This is going to break right there. That's how I'm going to do it. This is 12 by 13, so just 12 times 13. To find the area of that guy, which is 156, I like to circle my areas. Now I got to find this. Well, this is 9 by I don't know. Well, if the whole thing is 21 and this is 12, I should just be able to take 21 minus 12 to get our length here, which is 9. And then 9 times 9 is, 81? Add those two together. Now, if you put that 12 somewhere else, you're going to get a different answer. On the test, we'll make sure that if we do have a typo like that, we'll let you guys know. 237 is the area I got, and that would be in square units. I don't know what units they are. Find the area of the parallelogram. Parallelogram, well, area is just base times height. Remember, when we say height, I'm looking for a 90. That should be a 90 there, so I'm going to go with my base is 12. My height is 8, not the slant one. So 12 times 8 is 96 square units. Okay, and let's keep it going. All right, let's see. How much further can I get? I can get pretty far, I think. All right, find the area of a regular heptagon if the apothem is approximately 5.58 and each side is 14. Well, regular heptagon is 1/2 apothem times perimeter. So that's going to be 1/2 times my apothem, 5.58. Now I don't know my perimeter, but a heptagon is 7 sides, and I know my side length is 14. So if I do 7 times 14, I should get my perimeter. So my perimeter is equal to 98, so I do 98 there. So I just got to plug all that into my calculator. 98 times 5.58 times 1/2, and I should get my answer of 273.4. 2, it doesn't say by what, but my units are centimeters, so this is going to be square centimeters. Find the area of the triangle. Area of a triangle is 1/2 base times height. Again, we want to look for that 90. There should be a 90 on that. So that's going to be 1/2 25 times 14. Plug it in to your calculator. And we should get our answer of 175. I don't see units, so I'm just going to put a U. Square units. Find the area of a regular hexagon with side length of 8. Leave an exact form. So we gave you tons of space for this problem, which is awesome. But let's do it. There we go. That's a beautiful hexagon, 8. We know it's going to be 1/2 apothem times perimeter. So perimeter is going to be easy. Hexagon is 6 sides. So 6 times 8 is going to give me, what, 48. So that's my perimeter. Now, we're going to break this triangle up, and we want this little triangle right here so we can find the apothem. So we first want to find our central angle, which is 360 divided by 6. So 360 divided by 6 is going to give me 60. But when we cut it in half, this little triangle right here is going to end up with 30 here, 4 here, and we want to find the apothem here. Well, this is a special right triangle. This is in the L position. This is the L rad 3. So if that's 4, my apothem should actually be 4 rad 3. Leave an exact form. So we're going to get 1/2 and then 4 rad 3. So to do this on your calculator, this is what I do. I just ignore the rad 3. I just pretend it's not even there. I'm just going to do 1/2 times 4 times 48. I get 96. I write 96, and then I just slap that rad 3 on, and then my units. And because I want it in exact form, I don't need to. If I threw rad 3 in there, say I went back and did that rad 3, sometimes it works, and sometimes you get a messy one, but I just leave it out until the end. All right, trapezoid formula. Here we go. Area equals 1/2 the height base 1 plus base 2. Sometimes I'll write it instead of 1/2. I'll just write the whole thing divided by 2. It's the same thing. So height here is going to be this 90-degree piece, which is 10, base 1 and 2, 13 plus 15, and then divide by 2. So essentially, just make sure you do the 13 and 15 first. So this is going to be 10 times 28 divided by 2, and then 10 times 28 is 280 divided by 2. It's going to be 140 square units. Units squared? I don't know, something like that. Okay, I might stop here on part 1. Find the height of the trapezoid given its base measurements 10, 18, the area is 126. So if we have the formula right here, I'm going to fill in everything I have. So 126 is the area, so I actually have the A. Find the height, that means I don't have the height. I have the bases of 10 plus 18, and I have to divide by 2. So I just have to solve for this. So first things first, I want to get rid of that 2, so I'm just going to multiply it out. 2 times 126 is 252. And then H, and that just combine those, that's 28. So just divide by 28. And we do that, and we get H is equal to 9. All right, guys, so that's part 1. I think that was a lot. 66, so yeah, we got 30 more. We're good. We'll call it right there. Yeah, sorry, that was the last one, 36. Yeah, we'll see you next time.